Hi, ladies and gentlemen, welcome back from the short break, and we are going to talk about the examples I said, like a promise, under the resolutions of vectors, which I made mention of saying that we're going to give one or two examples so that you will get what exactly mean over there. Now look up, in this type of problem, we're given a question like, find the components of the resultant vector below. The resultant vector given to us is just 100 meters per second. That's the velocity. The component now becomes Fy component as the vertical component and Fx component. These are the components they want us to find. In this case, we have to bring out our data. So what we have is our resultant vector, which gives you 100 meters per second. And we have our f of y will be r sine theta, while our f of x will be r cos theta, and our theta is given as 30 degrees. Automatically, our f of y will be equals to r stands as 100, we have 100, then times sine of the angle, which is sine theta, and the theta I told you is 30 degrees. So what we have is sine 30 instead. So next I have is 100 times sine 30. You all know is 0.5. When you multiply this, like clean here, so what we have is 10 times 0.5, which is given as 10 times 5, which is 50 meters per second. That is f of y. Is it f of y even? It's supposed to be v of y, because we are using velocity instead of force, so we have v of y. Automatically here is v of y. Automatically here will be v of x. So what I calculated just now is velocity under the y-axis, or along the y-axis. So what we have is v of y everywhere. Now next is the horizontal component, which is v of x. That is v of x as the horizontal component will be r cos of the theta. So what we have is 100 times cos 30. Now we have 100 times cos 30 is 0.866. Those with calculator close them, they can punch it and see cos 30 is always 0.866 So what we have is, once you shift or you move this point here, we cancel this and cancel this. What we have is 1 times 86.6. So next I have is 86.6 meters per second. Therefore we have we have v of y. V of y equals to 50 meters per second, and v of x will be equals to 86.6 meters per second. These are the individual vectors that combine together to form this as resultant. If you want to check your answer, you can make a sketch like this with a y component as 50 meters per second as vy, while horizontal component as vx to be 86.6 meters per second. Definitely you find out this r to be 100 meters per second for sure. So that is it. We call this resolving the resultant of vectors. And remember, this is only one single vector acting at a point here. We have two vectors, like I said, that when you break this, you are going to have this way and this way. But it's not something you just break with hand or things like that, or you think of dividing 100 by 2 making 50-50. No, it's never so. Why? Because vector has direction, and that direction has to be in considerations when it comes to resolving whether it is direction or its magnitude. So that's why we cannot divide 100 by 2 and make Vy and V of X. We can never do that. We can't do that. What we can just do is to follow the respective processes of breaking it into two and make the component. Like I said, the vertical component is r sine theta. The horizontal component is r cos theta. That means this one and this one are the one that combine together to form this. These are forces or vectors acting perpendicular exactly 90 degrees to each other, which we use Pythagoras theorem to get this place. Now, no more use of Pythagoras theorem. What we use is just the trigonometric ratios to break the given resultant into two given components, which is a y-axis and x-axis, or vector along y-axis and the other vector along the x-axis. So this is what I can say about this example. Please, if you have any problem, you can comment on our inbox, say out your questions or say out whatever you think you have in mind, so that we can trash it up together and send the reply back to you. If you want it personal, you can use this number 070-3272-9581.